Okay, now we're going to switch gears a little bit and we are going to do the first of some lessons in this course on solving equations. This is an introductory lesson. Let's start out by talking about, well, a little bit of vocabulary. All right, an equation. An equation is actually a mathematical sentence that has an equal sign in it. A common equation would be x plus 2 equals 7. Now, a little bit more vocabulary. The letter X. X is a letter. It is called a variable. The word vary means changeable, and the value that X can represent varies. It can be any whole number, but only one whole number will be what we call the solution to this statement. In other words, a solution makes the equation true. Now, I understand that on many of the problems that we're going to look at, you can just look at this equation and say, oh, if I replace x with the number 5, I have a true statement. Therefore, 5 is the solution. And that's true. That is very true. But I want to talk to you about process, because as equations get more complicated, you can't see the answer. So there needs to be a process. I want you to think of an equation as a sentence, and there is a left side, an equal sign, and a right side. I have drawn down here, I haven't drawn it, but I have included a drawing of something called a pan balance. In the olden days, we used these, and if you wanted to get 3 grams of salt, you would use little weights and put 3 grams over here, and then you would pour salt on here until this lined up and it was in balance. But this is like an equation. Here's your equal sign, here's your left side, here's your right side. If you change the amount on the left side, that's okay, as long as you change the amount on the right side as well. So we're going to use that strategy when we solve equations. We're not going to just look at them and see what the answer is. We're going to do a process that will allow us to solve them. We want our statement at the end to say x is equal to 5. We know 5 is the answer. We know it's the solution, but we want to do some mathematical things to this so that it becomes this sentence. Okay? What we're going to do is look at x. We want x to be all by itself on either this left side, or if it's over here on the right side. It's important that it be isolated by itself. Well, there's a plus 2. I need to get rid of an added 2. The inverse of addition is subtraction. So here's what I'm going to do. If there is x plus 2, I'm going to subtract 2, which is its inverse, and it will make that will go to 0. 2 minus 2 is 0. But this is an equation. Keeping an equal sign, writing down the 7. If I subtract 2 from the left side, I must also subtract 2 from the right side. 7 minus 2 is 5. That's my process. I'm going to undo whatever is done. If I have 3, let me go back to the black ink. If I have 3x is equal to 15. Now when I put a 3 beside an x, sometimes you will see a dot. Sometimes you won't see a dot. But this means 3 x's, 3 times x. Well, what am I going to do to this equation? I like to draw this little barrier It makes me really think about left side and right side. What am I going to do to this 3x to isolate x? Well, the inverse of multiplication is division. I'm going to show that division in fractional form, so I'm going to divide by 3, and I intended to do that in red. There we go. Really messy. Can't stand that. So I've got 3x, still got my equal sign, got my barrier, and I'm going to divide by 3. That will, 3 divided by 3 gives me 1, so I will have 1x, and I don't have to write a 1. 1 times x is x. So, but I divided the left side by 3, so I need to write down the right side and divide it by 3. 15 divided by 3 is 5. And I could tell that, I knew that was going to be the solution before I got started, because what do you have to multiply 3 by to get 15? The answer is 5. I want you to practice showing these steps even though you don't think you need to. And it's in preparation for more complicated problems in your algebra future. All right, let's look at some equations that are like this. All right, I'm going to move that out of the way. The first thing I'm going to do is draw a barrier. I like to do that. I do it with a highlighter. I can do it with whatever I want. The left side has 42 plus m. Well, that's an added 42. What am I going to do to get rid of it? I'm going to subtract 42. Now I know that they are away from each other. Nevertheless, 42 minus 42 gives me m, because 42 minus 42 is 0. On the right side, I have to do the same activity. I have 43, but what I did was subtract 42 on the left side. So I have to do it on the right side. 43 minus 42 is 1. Now, if it bothered you to have this separated, we could do the following. I have 42 plus m is equal to 43. I want to get rid of this added 42. So I could say 42 minus 42 plus m is the same as 43 minus 42. So you can see that I subtracted 42 from the number here, and I subtracted 42 from the number here. So if it bothered you for them to be separated, you can put them together. 42 minus 42 is 0, so I just have an m left. And 43 minus 42 is the solution, which is 1. M is 1. And you could check it. Is 42 plus 1 equal to 43? And the answer is yes. I think I will do more of this as we go on. Let's look at problem number 2. In this problem, the variable, which is the letter, is over here on the right. I have 35 is equal to 11 plus p. I need p by itself. I don't care that it's on the right. That's fine. But I have to get rid of the 11. So I'm going to do a few things. I'm going to draw my barrier. And I have 11. I need to subtract 11 from it to get rid of it. I still have the plus p. But I chose minus 11 to get rid of that. On the left side, I don't have any choices. I must do the same thing. Subtract 11. On the left side, 35 minus 11, and if you need to, you go off on the side and you subtract that. So I have 24 is equal to P, and it's done. You could check it. 11 plus 24 is 35. It should not matter to you whether it says P equals 24 or 24 equals P. Okay. This time, the variable, the letter X, is on the left. Okay. I want it by itself. I have 33 I need to get rid of. So I will subtract 33. I still have plus X equals 40, and now I have no choice but to subtract 33. So the side with the variable tells you what to do. Subtract 33, the last problem was subtract 11. The problem before that was subtract 42. The side with the variable tells you what to do, but you have to do the same thing on the other side. All right, those 33 minus 33 is 0, and 0 plus X is X equals 40 minus 33 is 7. So the solution is 7. 7 is the whole number that makes that true. Let's look at number 4. And each one of these, I'm going to give myself some room. All right, how about my barrier where my equal sign is? Focus your attention over here on the right because that's where the X is. If the X is on the left, you look at the left. If the X is on the right, you look at the right. There is a 19 I need to get rid of. So I have 19. I'm going to subtract 19, but I still have plus X. On the left side, I have to do the same thing. I have 75, and I have to subtract 19. 19 minus 19 is 0, and 0 plus X is X. I feel good about that side. The left side, I have 75 minus 19. 9 from, I can't subtract, so I will borrow. Now it's 9 from 15, which is 6. 6 minus 1 is 5. I get 56 is X. So we have solved 3 equations. Each one started with a number plus the variable. This one was on the left. This one was on the right. Back to the left. And back to the right. And it didn't matter. We always use subtraction to eliminate this whole number that's been added over here. We're going to change up as we get to problem number 5. Still have my barrier through my equal sign. I still look at the side that has the variable, but now 9 is not being added to W. 9 is being multiplied by W. So you're going to do the inverse of multiplication, which is division. So you're going to divide this by 9. The reason you're doing that, 9 over 9, 9 goes into 9 one time. That's 1 W, which we will just call W. But if you did it on the right, you have to do it on the left. So I may need to go over here, excuse me, and do my division. 9 does not go into 1, so there won't be anything sitting there. 9 goes into 18. It goes 2 times. 2 times 9 is 18. Subtract, bring down the next number. 9 goes into 9 one time. I have a remainder of 0. I believe on all of these you will get a remainder of 0. So I have W, 1W, but I don't write the 1. And 189 divided by 9 was 21. And if you checked it, 21 times 9 is 189. Okay, so I use division. Let's look at number 6. This time the variable is on the left. I need X by itself. I look to see what's going on, and I see it is multiplication. So I'm going to do the inverse, which is division. I'm going to divide by 8 because 8 divided by 8 is 1 or 1x, and I have to divide 48 by 8. That gives me x. This one is an easier problem. I should know that as my multiplication fact. 48 divided by 8 is 6. So I have my solution. When you see multiplication, you use division. Next one, I have an equation to solve, and I see that my variable, my letter, is on the right. I see what's going on between w and the number I need to get rid of, and what's going on is multiplication. That tells me to use division, divide by 6. But if you divide the right side by 6, you divide the left side by 6. 6 goes into 6 one time, so I have w. Now let's do this. I have 270 divided by 6. 6 does not go into 2, so nothing sits above the 2. 6 goes into 27. 6 goes into 27 4 times. 4 times 6 is 24. I thought about my multiplication facts involving 6 and knew that 24 was as close as I would get because 5 times 6 would be 30, and that would be too large. So subtract, get a 3, bring down the next one. Oh, well, speaking of 30, 6 goes into 30 5 times. 5 times 6 is 30. Subtract, remainder 0. My answer is 45. I think we've just got a couple more. All right. In this equation, I have 6 times m is 2,520. All right. 6 times m. I notice it's multiplication. That means that to get m by itself, I need to divide by 6. That will take care of that. That's the easy side. I have to also divide the right side by 6. Always, always make sure you're doing the same thing on the left that you do on the right. That leaves me with a 1m. I don't write the 1. And I need to divide 6 into 2,520. 6 does not go into 2, so no number there. But 6 goes into 25. We did that a minute ago. 4 times 6 gives me 24. I subtract, and I bring down the next digit. 6 going to 12, yes, 2 times. 2 times 6 is 12. Now, don't stop at 42. There was no digit here, and most people don't write an X. That's just to remind me and to remind you that we don't have part of the answer there. But there must be a digit above the 5, there must be a digit above the 2, and there must be a digit above the 0. 6 goes into 0 0 times. So 42 would be the wrong answer. 420 is the correct answer. So be careful with your division. All right, one more. I have, once again, an equation that involves multiplication. That means that I use division. 8 divided by 8 is 1, so I have 1t. And I have to divide 3,424 by 8. So 3, 4, 2, 4 divided by 8. 8 does not go into 3, so nothing there. But 8 goes into 34. The closest multiple of 8 is 4 times 8, which is 32. I get 2. And I bring down the next digit. Does 8 go into 22? Yes. Well, 2 times 8 is 16. 3 times 8 is 24. So it's 2. 2 times 8 is 16. Subtract for 6. Bring down the 4. And then your 8 into 64 goes 8 times. Remainder of 0. Coming back to my problem, I have t, it's 1t. is equal to 428. Now, let me just say a couple of words of reminder. If you have x plus 3 is equal to 7, I know you know the answer, but the process, the side with the variable is the side that you focus on. You notice that it has an added 3. So, whoops. So you have x plus 3, and you will subtract 3. The opposite of addition is subtraction. On the right side, you have to do the same thing. Subtract 3. 3 minus 3 is 0. So you have x plus 0, which is x. On the right-hand side, you have 4. Now, how would it look different if you had 3 times x equals, let's say, 12? This time, you notice, whoops, so sorry. This time you notice that there's multiplication, and the inverse of multiplication is division. So I'm going to divide by 3 and divide by 3. All right, the 3's divide out. 3 divided by 3 is 1, and 1 times x is still x, is equal to 12 divided by 3 is 4. Now I did 2 completely different problems here, and I happen to get 4 both times, but when you see plus the x, or the letter, you subtract. When you see times the letter, you divide. Okay, now you practice some on your own.